So the last method for solving a system of linear equations is going to be the elimination method. So we've already talked about graphing, substitution, and last but not least, we have elimination. So let's take a look at 3x minus 4y equals 11 and negative 3x plus 2y equals negative 7. If I was to go ahead and add these two equations together vertically, I would get that negative 2y, because my x's would cancel out, negative 2y equals positive 4. We divide both sides by negative 2, and I get that y equals negative 2, okay? We can then go ahead and substitute this back in to either of our equations in order to solve for x. So I have 3x minus 4y equals 11, so I'm going to plug in y equals 2. That gives me 3x minus 4 times negative 2 equals 11. I go ahead and I've got 3x plus 8 equals 11. Subtract 8 from both sides. 3x equals 3, and then x equals 1. This means the solution to the system of linear equations is the intersection of these two lines at the point when x is 1, y is negative 2. In order to check that this is indeed the solution, I can substitute these values back into both of my original equations and verify that I get a true statement. So if I take 3 times 1 minus 4 times negative 2 equals 11, and negative 3 times 1 plus 2 times negative 2 equals negative 7, I will see that I get two true statements. So I know that this point is indeed the solution to this system of linear equations. So what are our steps to solving a system of linear equations using elimination? So the first thing is we want to make sure both of our equations are in standard form. That's ax plus by equals c. I know this is a little bit different than what we'd typically been doing, where we were looking for our system of linear equations. We want to typically solve for one variable, so we typically put them in slope-intercept form, but in this case we wanted to be in standard form. Then what we're going to do is we're going to transform the equations as needed using multiplication to get one pair of variable terms to be opposites. These are also called additive inverses because one undoes the other. For example, I could have 2 and negative 2 because 2 plus negative 2 is 0. Those would be an example of opposites or additive inverses. Next thing I need to do is add both equations vertically to eliminate the variable. We're going to solve the equation from step 3 for the remaining variable, and then we substitute into either of our original equations in order to find the value for our remaining variable. So let's work through a couple of examples. I have x plus y equals 5 and x minus y equals 6. I'm going to go ahead and add these two together. So I get that 2x equals 11, so x equals 11 halves. I then substitute this back into either of my equations, so let's take 11 halves plus y equals 5. I'm going to subtract 11 halves from both sides. Y equals 5 minus negative 11 halves. 5 is 10 halves. So y equals negative 1 half. So the solution to this system of equations is the ordered pair when x is 11 halves, y is negative 1 half. All right, for this next example, I've got 3x minus y equals 11 and 2x plus 5y equals 13. So I want to make sure one of my two sets of variables have coefficients that are opposites. So I could multiply this first equation by 5, and this would give me 15x minus 5y equals 55, and I could add that to my original equation of 2x plus 5y equals 13. That gives me 17x equals 68. I divide both sides by 17. I get x equals 4. I substitute that back in. 2 times 4 plus 5x, sorry, y equals 13. 8 plus 5y equals 13. I subtract 8 from both sides. 5y equals 5, so then it is the case that y equals 1. So I get when x is 4, y is 1. Now both of these equations had our system of linear equations intersecting at a point. But remember, there's two other options. They could intersect at every point, so there are infinitely many solutions, and they could intersect at no points, so there are no solutions. That means they're parallel lines. So what would that look like when I was solving by elimination those two types of problems? So let's make up a quick example. So if I have 2x plus 4y equals negative 7, and negative x minus 2y equals negative 1, and I want to go ahead and solve this by elimination, I could go ahead and multiply the bottom row by 2. So that would give me negative 2x minus 4y equals negative 2. And I add that to 2x plus 4y equals negative 7. Well, I would get 0, because both these cancel out, equals negative 9. This is a false statement. Remember before when we got a false statement, there were no solutions. That's because these lines are parallel. All right, let's do another quick example. What if I have x plus y equals 2 and 2x plus 2y equals 4? Well, in order to solve this, I need to cancel out one of my variables. So let's multiply the first equation by negative 2 on both sides. This gives me negative 2x minus 2y equals negative 4. And if I add that to 2x plus 2y equals 4, I get 0 equals 0. Now this is a true statement. That means that both of these lines are the same line. They're dependent on each other, okay? So this means that there are infinitely many solutions. The lines are dependent upon each other. And I could write this solution as, I want to write this solution as the points x, y, such that they are on the line x plus y equals 2. So that would be our solution.